So welcome everyone, we're going to have a look at this first problem. So we need to prove that opposite angles of a parallelogram are equal. So our required to prove is that angle DAB. So DAB, remembering we're always going anti-clockwise, is equal to angle BCD. So B to C to D. And that angle CDA is equal to angle ABC. So CDA is equal to angle ABC. So our first step with doing any of these types of problems is always dividing into two triangles and then proving congruence. So we've already got the line drawn in from D to B, so we've got two triangles, and it doesn't really matter which way we name them, so long as we are consistent in our ordering. So we're going to prove angle DAB is congruent to angle DCB. So I always like to start with any sides that I know that are equal. So looking at the two triangles, I've got this line together, which is a common line. So I've got DB is equal to DB because it is common. So we've got U done. So are there any other sides? So we're using the definition of a parallelogram, which is that there are two sets of parallel lines. So we've got one set of parallel, one set of parallel. Now, we know that with a parallelogram they are the same, but that's not part of our base definition, that we've got two sets of parallel lines. So we're going to have to look at any sort of rules without angles. So what were our congruency rules? We had SSS, SAS, AAS, or ASA we can also call it, or RHS. So we have only one side, so we're not going to be able to use SSS. SAS we need two sides, so that one's not going to work either. RHS, well, we need a hypotenuse and a side, so that's two sides as well. So our only real option of proving congruency is going to be with AAS or ASA. So using AAS, we're going to need to find two angles that are equal. So looking at our triangle, we've got a parallel line and a transverse across those two lines, which essentially is our Z rule. So with our Z rule, we're going to have these two angles which are equal. So we've got our two parts of our Z must be equal. So we need to use our proper naming convention. So once again, we're going anti-clockwise, anti-clockwise. So ABD and anti-clockwise CDB. Great work, we have one done. So we've used this Z. We now need to find a second Z that we can use to show congruence. So we've got a parallel line here and another parallel line here with a line going back like that. So we've got another Z sitting up that way. So we'll put our Z in. So we've got this angle, which is BDA, being equal to this angle, which is DBC. So now we can start to name our triangles. So remembering we're using the same order. So if I go from starting at the two dots, for example, so I've got D is the two dots, B is the two dots, A, and then is the same as C, and our final one, which is our one dot, which is B, and our one dot is D. And these are two triangles that we are saying are congruent because of AAS. So now, because these are congruent triangles, we know that these two angles are equal. So we can say that angle DAB is equal to angle CDA. Note that these two statements here need to match. Now, because our triangle has here, we've labelled without dots, we've got 1 dot and 2 dot, and 1 dot and 2 dot. We know that this entire angle, so CDA and angle ABC are the same because they're constructed by the same two angles together. So we know that angle CDA is equal to angle ABC. And we're done.